Right, so let's come out here to Brian Ropar's ham shack. Let's see what we got in here. We got the crystal set, RF to DC, everything's set up in here, so let's sit here and play at this for a second. Right, so basically this will pick up AM radio. So let's hook it up. I got this Dr. Gallagher on there. Yeah, we got Dr. Gallagher. Listen to all that stack on there. We don't want to hear about your thyroid there, lady. That's spark. Look at that spark in there.
Thyroid and then
You get the idea there. So, what else we got? This is a LM3-6 circuit there. Got this ground tap. So let's say a little tour around this place. We got ground rods in each corner pounded into the ground. We got a grounding ring the whole way around and under the floor. Ground rod there. We got grounding there. Here you see a grounding tap. Basically a piece of copper pipe. I wrapped a ground wire around that and we have this tap coming off of it. We got 3 coax cables in here, dual coax with ground, or should I say RG6 with ground. We got a RG6, should I say dual RG6 with ground and an RG6 with ground. Gone to these 3 grounding blocks, and I got my crystal radio connected to one part of it. I got this for experiments connected to the single coax. I got my RF to DC converter. This basically takes radio frequency out of the air and turns it into usable electricity and lights this LED, but you can see it's barely blinking. I tell you what, that is not free energy because the power source is the radio station is transmitting the electricity. I mean, I wish it worked that way, but no. I tell you what, if those radio stations were not powered up, you'd get no power through that RF to DC converter. And if you look under here, this thing is a giant one-source machine. Electrostatic motor, I'm going to do. I got my mirror sitting there for the telescope I'm going to put on the roof of this thing. Right now we got some pretty good sky. You can see how I'm going to build the telescope. It's basically going to go right up on top of that. You see the scooter wheels. It's basically what, 1, 2, 3, 4, 5, 6 octagon, whatever that is. Octagon, pentagon, whatever it is. Pentagon's 8, whatever it is. Anyway, you get the idea. I mean, you can see how this is coming along. And basically, I'm going to build a telescope. It's pretty much going to, when I focus it, it's going to transmit whatever I'm looking at onto this dry erase board here, and we'll be able to study it closer. So let's come out here and look at what I got. I got my solar power ready to go. I got this pendulum sitting out here. I tell you what, if you stick a magnet on this and run it to a sensor, every time this moves, it'll vary the magnetic field and it'll transmit signals whenever that moves. Come on here. So basically, the telescope I'm going to build up here is going to have like 3 functions. Well, you got focus, spin it, raise and lower it. So I'm trying to make these so I can adjust it with a rope. One will spin it, one will change the angle, and this one will like focus it. So basically I need like 4 mirrors. You're gonna need a primary mirror, the secondary mirror on the end, and it comes back to the focusing mirror. And then the focusing mirror goes to your optical equipment that basically transmits this down here, and basically how you face the 2 mirrors towards each other, that'll change how big whatever you're looking at is. And the focus will adjust to clearness, and you can pretty much find a star and zoom in on it and look at it, and we'll cover this more in detail in another video. In some cases, bigger is not always better, like these picofarad capacitors. I mean, and the diodes. Now you'd think you'd want big stuff, but no, not really. You want fine, small parts of this. So you want very minute adjustments. You can see the big dipole I got set up here. Goes all the way up to the tree and over the chimney. Anyway, you get the idea. Anyway, here's Brian Ropar's amateur radio shack.